Okay, now we see the problems. So based on milli equivalents, so which are somewhat different. So compared to the earlier classes problems. Okay, so maximum we are discussing the problems. Only one or two of similar models. The maximum we are just taking selecting different models only. Okay, so here see the problem. Metallic tin is oxidized to its maximum oxidation state. When here the tin is oxidized to its maximum oxidation state. So we know that the tin is present in two types, Sn plus 2 and Sn plus 4, stannous and stannic. So here it is given that tin is oxidized to its maximum oxidation state. Mean here given that tin is oxidized to stannic, that is plus 4, by oxidizing agents potassium permanganate and potassium dichromate. Here both reactions are separately in acidic medium. Now we need to calculate the ratio of the values of decimolar solutions of potassium permanganate and potassium dichromate, these oxidizing agents, which are reduced by 1 gram of tin. Here see, potassium permanganate, potassium dichromate are oxidizing agents. So they oxidizes the tin. Nothing but tin reduces the potassium permanganate and potassium dichromate. Here we need to find that 1 gram of tin, we need to find the volume of potassium permanganate and the volume of potassium dichromate, which are reduced by 1 gram of tin. And 1 gram of tin, and the volume of the potassium permanganate and the volume of potassium dichromate ni reduce chesadi. We need to find that value separately and find that ratio. Okay. Now we separately find their values. Okay. Now we do the problems separately. So that is here the tin becomes Sn plus 2, its maximum oxidation number, that in fact equals 4. Here MnO4 minus potassium permanganate, the ion is MnO4 minus, it changes to Mn plus 2 in acidic medium. Here in fact is 5. So here we can write we need to find the value and their concentrations are given as decimolar. So these two are reacted completely. MnO4 minus oxidized tin is reduced the MnO4 minus completely. So the equivalent of Sn is exactly equal to the equivalent of MnO4 minus. So the equivalent weight of tin means so what is the equivalent weight? We know that always weight by gram equivalent weight. Weight by gram, we are calculating this part now. So weight by gram equivalent weight means so equivalent weight of MnO4 minus. So equivalent weight of MnO4 minus nothing but its molarity is given 0.1. Its normality we need to convert it to normal, that is into n factor and into its value. Here weights by equivalent weight. Weight is given 1 gram. Equivalent weight means molecular weight by Molecular given as 118.6 by 4. So therefore 4 by 118.6 equals 0.5 V. So the V is equals 4 by 118.6 into 0.5. So that is equal to and the value is finally we got 0.067 milliliters. Now we do the same calculation, same type of calculation for potassium dichromate. Okay. For potassium dichromate, in K2Cr2O7, Cr2O7 minus 2 change it to 2Cr plus 3. Here in fact is equal to 6. 3 electrons for one chromium, 3 electrons for another chromium, is it becomes 6 1. And we do that for tin it is 4, means equivalent of tin exactly equal to equivalent weight of Cr2O7 minus 2. So what is the equivalent weight of tin? Again we know that already here. 4 by 118.6, that is equal to Cr2O7. So equivalence means what is not molarity is decimolar means it's 0.1. Here there is no information about the weight. If the information given in terms of weight, we can do that same in terms of weight by gram equivalent weight. But here the information is not given in terms of weight for potassium dichromate and for potassium permanganate. That's why we are taking the other information, molarity into its n factor normality and its value. Here value we are taking equivalence. If you take milli equivalence, then we can write milliliter. We are taking equivalence, we must take it in liters. So sorry, it is in liters. Point that is equal to 6 into value in liters. Again here we equal to 0.6. Here we get 0.073 liters. So the question is, we calculated, separate them. We need to calculate the ratio. Okay, ratio means the value of KMnO4 therefore the value of KMnO4 by the value of K2Cr2O7 equals 0.067 by this is 0. We will get 0.05. This is approximately 6:5. Okay. So here the simple one, normal problem, we used to calculate only the individual one. Here we need to calculate the two problems in one problem. So that is tin comparing it with MnO4 minus. Tin is reduced, tin is oxidized by KMnO4. MnO4 minus is reduced by tin. Comparing these two, we will get this value. Here compared with the separate, the experiment are done in separately in acidic medium. Here potassium dichromate tin, comparing tin equalizing with the equivalence of both, we will get the value of that potassium dichromate. So they are comparing the value, we will get the 6:5. So this is the general procedure for this calculation, and we can do in a shortcut method. That is, their values are reciprocal to their, for example, value of KMnO4 by. So this is a alternating method. So that is equal to, their values are always inversely proportional to their n factors. That is 1 by n factor of MnO4 minus by 1 by n factor of Cr2O7 minus 2. So that is equal to 1 by 5 and 1 by 6. Here we get okay, just remember that the values are always inversely proportional to their n factors. Okay, this is the alternate method for it, but general method, so we need to prefer the general method normally. Okay, see the next one. So on heating 1 liter of 2 normality HCl solution, 36.5 gram of HCl is lost. Here 36.5 gram of HCl is lost in this reaction, and but in this change, the value of the solution is reduced to 800 milliliter. So on heating, what happened to the 2N HCl of 1 liter? The 36.5 grams of HCl is lost. Means here we don't know the initial weight, but it is given that 36.5 grams of HCl is lost in that heating, and the value is reduced to 800 milliliter. At first it is 1000 milliliter, that is 1 liter. It is reduced to 800 milliliter. So we need to find the normality of the resultant solution, means normality of final solution. So at first, so before doing these two calculations, we must know the what is the initial weight. We must calculate the initial weight of HCl. Calculating initial weight of HCl. Initial weight of HCl means, so what is the initial solution? 1 liter 2N solution. So what are the milli equivalents? Milli equivalents of HCl equal to its normality into volume in milliliters. So what is this normality? 2. So what is the value? In milliliter, that is 1000. Equal to 2000 milli equivalents of HCl is present initially. But we need to know the weight of that HCl, initial HCl, to find out the normality of final solution. So we convert it into weight. Already we know that milli equivalents means weight by gram equivalent weight into 1000 by volume and V. So we will get cancelled here. Here 1000 ml, 1000 will also get cancelled. So that is equal to 2000. Here weight equal to 2 into, what is the equivalent weight? Equivalent weight of HCl is 36.5 by 1. So therefore weight equal to 73 grams. Now we did the two calculations separately. The normality of resultant solution and the final solution lo how much value 800 milliliter only. 800 milliliter lo and the final value in the final value is 800 milliliter. But to find the normality, we must know the final weight. So we know the gram equivalent weight into 1000 by volume in milliliter. This is the formula for normality. But we must know about the weight. We know the value is given as 800 milliliter in the final solution. We know the gram equivalent weight of HCl. So what is the weight? So weight is already, the initial weight is 73 grams, we have got it. But it is given that during that on heating experiment, that 6.5 grams of HCl was lost. So what is the final weight? What is the final weight of HCl now? Initial weight minus the weight lost. Means 50% of weight is lost. So now substitute in it. So weight, same gram equivalent weight. So here it is equal to 10 by 8 means that is approximately 1.25 normality. Means the normality of final solution is 1.25. Next we calculate the B. So the number of equivalents. So already we know the milli equivalents in. So milli equivalents in 1 liter, how many are there? 2000 milli equivalents. But it is the question is we need to find the equivalents, not milli equivalents. We need to find the equivalents. Equivalence of HCl in 100 milliliter of that original solution. Means not about the after reaction. It is totally about the initial position, nothing but before heating. So before heating, milli equivalence of HCl initially equal to 2000, and that is in 1 liter. 1 liter nothing but 1000 milliliter of HCl is equal to 2000 milli equivalents. Then what about 100 milliliter of HCl contains how much milli equivalents? Okay. So that is equal to 200 milli equivalents. Means in 100 ml of original solution, it is having 200 milli equivalents. But the question is not milli equivalents, not milli equivalents. We need to find the number of equivalents. Number of equivalents means power minus 3. Okay. So that is equal to 0.2 equivalents. So the number of equivalents present is 0.2 and which is equal to 200 milli equivalents. Okay, so take the problems and practice the same type of problems in your reference book. It's compulsory. We will check the notes after opening the school. See the next one. Now, how many moles of HgI4 minus 2 will be formed when 2 moles of mercurous and 2 moles of iodide react as following? Such that the equation is given in the book. In question, the question itself has this equation. So we need to find the moles of, just not the amount, not the volume, just the moles. we will get directly from the equation. The moles of HgI4 minus, the given information is with 2 moles of Hg plus 2 and 2 moles of I minus 2. So if only one reactant information is given, that will be very easy to compare that given one compound information and compare it with the product value. But here the two values are given, nothing but the information about the two reactants are given, that is 2 moles of I minus and the 2 moles of Hg plus 2. So this will be solved only by taking balanced equation. So in this given balanced equation, the 1 mole of Hg plus 2 react with 4 moles of I minus, forming 1 mole of HgI4 minus 2. So there is no change in it. This is the basic one for this balanced equation, nothing but for this reaction. So we need to compare the given values with it. So what are the given values? 2 moles of Hg plus 2. So the given values are 2 moles of Hg plus 2 and 2 moles of I minus. We need to find out this. So here important one, the 2 moles both are in same, but in originally they are in 1:4 ratio. Means according to the balanced equation, we can say that 1 mole of Hg plus 2 can react with 4 moles of I minus. 1:4. If you apply this for the given values, the 2 moles of Hg plus 2 should react with 8 moles of I minus. But there is only 2 moles are given. Means the 2 moles, this is in less amount. This is in very less amount. Here for 2 mole, here 1 mole, it requires 4 moles. For 2 moles, it requires 8 moles. But here only 2 moles are given. Means this 2 moles of I minus is limiting reagent. So this is limiting reagent. Now we continue the problem with this I minus. Just left the value of these 2 moles because it is in higher amount. This total amount cannot be reacted with I minus because for 2 moles of Hg plus 2 requires 8 moles of I minus. But there is only, the availability is only 2 moles. Means this 2 moles of I minus only totally consumed. 2 moles, the required amount is less for I minus. By comparing these two basic balanced equation, which is in lesser amount in a reaction or which consumes the total in a reaction is called limiting reagent. With the help of by taking the limiting reagent only, we need to continue the problem. Then whatever the other information means, it is in excess amount. It is in excess amount. So we can't continue the problem with this one. So we compare these two only now. Okay, according to balanced equation, the 4 mole of I minus can produce 1 mole of HgI4 minus 2. Then we have to calculate what about for 2 moles. 2 mole of I minus gives how much? Okay, that is equal to so 0.5 moles of HgI4 will be formed. 0.5 moles of HgI4 minus 2 is formed. Okay, let's take it.